Okay, go ahead.
Yeah, so now we go online. We have online version, this one. So we have a domain name like dfttk.org. At least for this presentation, we use this web address. Then after, click this web address, you see here, this is our online document. So first I'll go to the how to install the package. Click installation. See, this very regular one. Of course, it requires you have an Anaconda installed already. So I think in our case in ACI, this already installed there. If no, I mean, anybody here in our group already tried, like you can ask for them. For simple installation, you just need one line of command, just pipe install. That can help you install all the software, major software for DFTTK. Then for this one, you need to make some folder like DFTTK something because you want some kind of environment. Then you make a folder by the Linux command, go to the folder, then type a command DFTTK config mp ACI. This one just works for just our ACI. This just copy everything. See, because many of you already perform some calculation, you need some kind of supporting file like the pseudo potential. So this one can help you set up those kind of environment. Also, you need some kind of backdrop environment. In ACI, we use PBS. This one already can help you set up those kind of one steps down. So majorly, if you only want to do 0K calculation, this is already enough. If you want to contribute, like in future, Xuan want to do something, help me to implement the like something like stacking for calculation. Also maybe Shun Li. I mean, writing Python code quite easy, straightforward. Then you can try to install the developed version. Basically, by install this regular version, you have a default path, everything installed there, but you cannot change it. You can still make a change, but there make it a little complicated. If you want to contribute to your work, I mean, to expand the DFTTK, you can always do something like here. First, copy this one. I think in the ACI already installed Gate. So basically, this line just copy the DFT package from our group website. You see here not from group website, it's something from GitHub, but the name is our group, physical research lab there. And basically, this command just copy that all the source file from this website. Then you go to the folder because you need to create this folder like here. Then go there, then do pip install. This one just install everything in this folder. Then you can make any change. Then here, directly here, if you want to do your own contribution to the code, then again, go to here, something like go back there, just go to the folder and do a configuration. Configuration, that means, like I mentioned, that the configuration, the pseudo partition file or PBS environment. In ACI, we are using PBS system to manage the batch job. But in others, like NERSC, they are using the new one called Slurm. Also, here there will be next step, stage. This stage, I put the YiWang package separate. I should have make it in a YiWang package
together, right?
Together but right now I just for the fast using group because this one is like YiWang. I think Jorge already installed and 3D also installed. So many people that also Hongyun is also installed because this one that Linux one. My one is something I even don't need installation. You just use the tar file and save it, then adding the Linux environment. That's all. In fact, I do something put here, but I still learning, how this one I put also the GitHub. You can just copy this file. This one easy, this save your time. You see copy tar file. This one exactly go there, copy this file and unsave it. Then go once upon your see you have some, this one will create some kind of folder there and go to that folder, then set some This one, you know, even this step, even you don't need it, because this one, you know, the Linux system, the binary file or look like can be run anywhere as long as you have a Linux background and environment. If this one even can escape, then you need to set something the Linux, you know, you are using the Linux, something you already familiar with Linux. So you just need adding the YiWang part, pass the binary executable code to the executable search path. Then that's all. Because sometimes DFTTK, there if you want to find the temperature calculation, I convert, the host processing the DFT calculated data by YiWang. Then this one just for if you're using CSH, and this one if you are using regular people are using BSH. Because I have been used to using CSH environment for last 30 years, so still I do use this one. But for BSH, you still can use this one. Then, you know, if you go ahead, next step is says, you know, in addition to the configuration environment, you need some kind of access. We have data saved in our MongoDB database. Virtual machine run by, now we move to from DigitalOcean to PICO virtual machine. So I can send you such a file. I can use your, you know, if you want, just send me email. I based on your PICO ID. I can produce this file and send this one to you. You can copy this one to that folder called configuration. There, here I'll have very detailed instruction here. I go to that configure folder and copy this one. And then that's all. Of course, sometimes if you want to do something to check, see, manually, you can also directly access your database. Then can you install something free software called Robust3T. Of course, this way, currently, by PSU, you need to install the VPN first. But this one is not necessary. But if you are interested in one, you can just install this one. See, I'm using this one to handle the, I'm data here. If I set up this stuff here, so you see here, we have this one use the PSU one, PR virtual machine, and this one is DigitalOcean. In fact, I have a lot of data saved here, but here, you know, basically I do connection. See, maybe I can just close this one. See, tell the step here, this is the Robust3T. See, this you want to connect, see here. Then here you see something here, I'll just tell you a step. You want that manually. Sometimes you still need manually check what is finished. Then you see you don't need to change this one. But here just show what the parameter you need input there. See here just arbitrary name. Okay, I just use one that represent, you know, our physical research lab virtual machine. And this is the IP address. You should use this one. Also for default IP port, I learned this one. I even don't know this terminology, but I learned this one from Brandon. So the default one is 27017, but we use the 27018 because we have been using this one in the DigitalOcean. Then this just everyone use same one, but here, you know, this one just here. So if you use this PSU ID is my one, but this name really can be any arbitrary. If you want, I can use your name, that give me. Otherwise, I can use default PSU ID. Basically, you need adding this line here, and this is the PSU ID, or just any name. But this one should be same, keep the value the same. That's password. This one just the one I send you called db.json file. This setting here, and this one you don't need. And also just this one, putting the same thing here. Then that's all. But I just see once you set up this one already, then just save it in your computer already. Then next time when you try to connect, oh. See this one, it will connect. Then we'll connect to your database. See this one show you all results. See, then go to here, see what you have, collection here. Then you have a lot of calculations here. See, they have some funnel there. They have, of course, this one just some raw file there. You want to check that one. Then this one, you know, one of the purpose DFTTK just help you, you know, access all the file saved here. See here, you see, in fact, we had entropy already calculated here, heat capacity here, but this one just for individual volume, also for here for different temperature, corresponding different temperatures. Here we do calculate for 400 temperature, all saved in the database. Then DFTTK will help you access this data to have whatever easy to use for our to make plot or other stuff. This is an example. If you connect one for DataOcean, it's the same thing. But I think we already migrate our data from DataOcean to our. But by this software, you can also open the data there. I'll say that open something rather problem there, but setting when I didn't set it well, but look like it's just something there. They have data or same thing there. So now go back to our website. So this is just installation. Up to here, you finish all the installation. You see here, that's from this page. Again, I want to repeat there. See, by this website, click installation. If one, for most people, if you want just 0K calculation, just do this one line is already enough. Pipe install DFTTK. That's all. Then after this one done, I have one example there. After install it, everything done, then you can do one sample calculation. Basically, after you install this one, you will see some kind of folder called example folder. Then have one folder, there are examples there. You have one aluminum one. I'll use aluminum one for example for this, go through the test process. In this folder, you have, maybe I should go to, I need to connect this one. See. So this one now I'm using I changed to from the Mac one to the Windows one. In fact, Windows one for the SS connection is better than the Mac because this one can save all the data you needed. Because this one you only need to input the password one time. So I like this one. This one take a little bit more time. Here, right here, because I work in the morning. But here, when the help this one is once this one is called the bit size, bitwise putty. Once this one open, you can open whatever number of windows you want. See, because you don't need input information for one more time. See here, you can open whatever you need. You want. I have my where's the ink? Excuse me. Here is the example folder. Then go to here. The input file here. In here, into calculate, you only need to input one file. In fact, two if you want to do funnel. If just 0K calculation, you need to provide only. Yeah, just something like the postcard already know it. You already did quite many calculation. But if you want to do further funnel calculation, when you set this file, just use the settings YAML file. So this that tell you to funnel calculation on the supercell side, this supercell transformation matrix. That's all. After this one, you just to try the calculation, you just need to run this command. So this line, this one will submit a job. Yeah, this one just submit job. Here, the meaning here, I want to see that this one just we just use this name. Later we'll change this one. The robust, this one developed by Mingqing, call this workflow. This one called workflow. You just call same thing. Here maybe just use this postcard file. Here one call something called the launchpad by Pamage. This one just see how many jobs do you want to run in a computer. Here just list one job. if we do something here, then just because I'm just testing. Because the first hard one here, it invoke will invoke the Python environment. Then take about 1-2 minutes. The next time will be faster. I mean, every time I open the new window, you will see something like this one. But this one will tell you a little bit the setting up of your environment. After that one, that's basically all your job finished for DFT0K calculation. Then you want to do something like finite temporal properties, you can just type this command. This one a little bit longer because I'm going further. But I already have results in there. This one just is not here the code slow because this one when first run here need loading the Python environment. Yeah, you see here that produce something called job there. You just need wait there. Then this one just submit. You see, see already have job submit there. Then it's done. But anyway, after the job is done, you just can. Then you can try write command to. If once the result done, you can try just make a test. Maybe I can you go another folder, but because I don't, you can use any folder name. So you can basically now you can try to extract your result. Basically, just type this command. So you can just do this one. The last one you see here, a lot of stuff here, you just keep the same as I use here. This one still on the test stage. Literally, I put all this, here as default there. Right now, I just use this one. This one basically, one thing only this you need to change because this represents something like a column material ID or just the calculation ID. But this one from last work I finished saved on this file. Let me see here. This one basically for to extract the result finished for the maybe because of the pass here. This one just maybe I don't because this one see something is run data. If no gets run data, just this one just finished the calculation for the post processing. Because it's just the started job. Take about a couple minutes we're done, but maybe I can open another window. Oh, no, I can use another one. I already finished one. But here, just say we do calculation to multiple volume. Here we have 7 volume. So this one just finish 1 volume, second volume. But next run this one, because DFTTK will check the each volume with the calculation done. Then next time we'll see more time. This one just, and after run this one, you can produce something like this folder. This one tell you all the result. Here, see quite several files. See, this is elastic constant there because that calculation I already have elastic calculation, temperature dependent calculation there. And here's some explanation. Maybe most useful is this file. This one basically all the thermodynamic properties. Sometimes by Linux, automatically, if one line too long, will just, it will wrap there. But if you do something using set no wrap, you see here by each column. Here you see the heading there. For each column, the heading means the temperature, volume, all the stuff. And if you want to see some kind of calculated figures, all the data here automatically, make a plot of figures. See in the figure folder, I have plenty of them. You can just use some command like a linear command called display. This is from magic something makers. It's called image maker. See, for example, for some expansion, I use this one. This one a little bit slow to display the figures, but quite still comparable. Here does some expansion. Another example, if we have, you can check this one by one, but here you have more than 20. So you want to see the figure of heat capacity. Here quite many different plot here. Yeah, all this temperature depend, temperature heat capacity. Because here I have that experimental data there, still there. So here. Then also you can see something here, but for example, another one is for the here basically I want to see something for demo purpose. We want to show something about the host friendly, dependent on volume and temperature. You find back this list here, see a lot of the property lists there. So we have the data there. This one called the image maker. See, it's UV curl, friendly, I found the volume and so temperature here, the labels for different temperature. And here also can do automatically calculate for phono dispersion. Here they almost go that step here. See here automatically produces SGTE fitting. I think this is almost done, but like next step. This one, after done this calculations here, produce automatically a file here. That's that one. This one just, the one we just finished. And this one, I want to see this file is that the temperature dependent of the elastic constant. Still here, sometimes I need to refine the data, but here that tell you about what is C11, C12, and C44, and Bach modulus. Young's modulus and Share modulus, and temperature dependent. Here, because if you put some experimental data limited there, we'll do only calculation at 933. But if no temperature environment there, we go to some time until the calculation go to abnormal. But I was fine. I think I have recently have some data there, experimental data. But I'm not finding there. Let me try to find out. Basically now it's done. So this procedure for the calculation. I think I have one experimental data there. Oh, I see. We do something like this way. I think this data is I think the data is there. I have experimental data here. If you put adding experimental data there, then the system will also pull out experimental together. Because that one I just using some JSON type file to to verify, to check the calculation. I collected some experimental data and save them in the folder. But anyway, basically now the procedure and test run for DFTTK is done. Of course, here you can see some other knowledge. When you run job, you sometimes have a job, failed. Then you can see here we have also instruct how to check your job. Basically here, you can check this command, how many your job finished, how many material there, will show that one. You can go by this page. Here just for what criteria, you can select certain material or which, what system you have ternary quaternary stuff here. Then this DFTTK can help you extract those data. Sometimes I prepared also some troubleshooting. Sometimes you have, sometimes always system is changing. When you see here, sometimes you need your batch job, you need to have some line there in the PBS system. Then you add one line in your configuration file. Sometimes, if you really cannot wait too long, right? Like here, see, take about a few minutes. You have, see, 100 calculation. Then you need adding one line here in the batch job. Because this is something like if you have calculator with something like omega, that's calculator, then if run by terminal, no problem. By your batch job, you said, okay, that the character cannot be displayed, the job will be just abnormally terminated. That's the solution for some troubleshooting is I prepared. Then another stuff here I prepared, maybe this one not for our group, for our software used by other persons. Then I prepared a little short stuff here because I learned this one from in this stage, learn how to set up, virtual machine to manage the MongoDB database. Then we have this one. To how to install the MongoDB. If in the future our group, we don't use the virtual machine, we bought a PC and install the PC in our physical research lab, we can just set up our MongoDB in such a way. This one how MongoDB operation and how to produce adding user or stuff here. I already complete this file. In fact, you see here, this file we used for this one we send to user. If you are system manager and use code here, the code I got that code from Brandon by change a little bit, make more easy, then produce some file there. Then when very easy, make it easy to set up the MongoDB. Now also other stuff here, this one the original from Brandon. See what will be some other stuff like the calculation of the SQL structure. Here I also adding something like the questions there for how to use this one. This one majorly this one basically still from Brandon. Here just for developer purpose for progress, they record the timely progress of the code. And also here again, see how do you can contribute to the lab this one, like Xuan want to do something, then you can here check here how to do that one. Basically, right now it's in shape, but every section here need a little bit more detail, but roughly can give you a lot of help. Here, even after you contribute to one, you see you can make a contribution. Here, this again from original prepared by Brandon, but after that one, I tried, during the process, I learned also a lot of operation about how to handle the gate stuff. Maybe if you are interested in one, you can learn it from here a little bit. I think up to now, of course, I have this one. Just go back here, the function here, a little bit of introduction about how you use this one. But this one also you can download something here. I think the PDF version of this one, if you want. By that one, by I have one, but if you want PDF version, I can copy, give you one also. I think somewhere here you can convert those file download together to PDF one. But I think this one you relatively easy one because you see click here, can go to that directly that page. Thank you. That's all from me. Do I have any comments or questions?
YiWang, I have